In injection molding, a flash refers to excess material that escapes from the mold cavity during the molding process. This excess material typically occurs at the parting line or mold edges. Flash can be caused by various factors such as excessive injection pressure, improper clamping force, inadequate mold alignment, or worn-out mold components. It's considered a defect in injection molding because it results in extra material on the final molded part, which can affect its dimensional accuracy, appearance, and functionality. These parts are usually discarded as bad parts or require post-processing to remove the excess material and achieve the desired part geometry. To prevent flash, Woojin developed the flash monitoring function, which can detect flash formation due to mold breathing. The option is designed to assist the machine operator in finding the optimal injection pressure and clamping force to prevent a flash formation. Let's take a look how the option works from a technical standpoint. During injection, the pressure acts across the mold surface onto the mold parting line. This force is opposed by the clamping force, which needs to be high enough to prevent mold breathing and flash formation. Potential mold breathing can be detected with fluctuations in the clamping pressure. Woojin does not need any additional sensors or special hardware to detect these fluctuations. For this, on the DL machine series, the tie bar pressure sensor detects changes in the clamping pressure. On the toggle machines of the TE and TH series, the clamping force is monitored with high-precision tie bar tension sensors, which detect potential mold breathing with an increase in tie bar tension. Now that we covered the basics behind how the function works, let's take a look how the interface looks on the visualization. The option is enabled in the top left corner with a checkbox. After that is done, the only thing the operator needs to adjust are the maximum force levels during the injection and holding pressure phases. These need to be determined manually by the operator during mold commissioning. Once the commissioning is successfully completed, a good reference for these values are the actual maximum forces that can be seen in the table. Based on the set references and the maximum threshold factor during each cycle, the operator will be informed about the status of flash monitoring. This notification will appear at the top of the screen, giving the monitoring status and the maximum values of force and the threshold. Depending on the threshold value, the notification will tell if everything is okay, or if there is a moderate or high chance of flash occurring. If it's the latter, then the operator should inspect the produced part and adjust the injection or clamping settings to avoid flash formation. To assist with the correct setup of the injection profile, the operator can analyze the injection profile graph. Here the violet line represents the threshold factor. Looking at the peaks of the graph, the operator can recognize when the mold cavity is full, and optimize the injection profile accordingly. By doing this, the pressure on the mold parting line decreases, preventing overpackaging. If mold clamping force needs to be adjusted, it can be done on the mold page. If flashing is still forming on the produced parts, it is advised to inspect the mold tool for misalignment or damage. On the bottom of the page, the user can track the maximum threshold factor of previous cycles. Number of shown shots can be adjusted by moving the slider beneath it. We hope this video tutorial was helpful. If you have any other questions regarding flash monitoring, please leave a comment below, or contact us directly through our customer service channels. Thank you, and have a nice day.